All right, so hey guys, this is going to be your video for me going over the homework on the polar derivatives. So for the first one, we've got r equals 1 plus sine theta. We want to find the derivative, slope of the tangent line, at theta equals 0. So we're going to need x, and we're going to need y, and x is r cosine theta. So it's going to be this times cosine theta. And y is r sine theta. So it is going to be this times sine of theta. And so when we do the derivative, it's going to be dy d theta over dx d theta. So these are both going to be product rules, which makes this get kind of long here. We're going to just look at this one first. So product rule is the first times derivative of the second plus the second times derivative of the first. And then we're going to do the exact same thing for dx d theta down here. So first times derivative of the second plus the second times derivative of the first. And then we're going to evaluate this at theta equals 0. So we're going to plug in 0. So sine of 0 is 0, plus 1 would be 1, and then cosine of 0 is also 1. So this entire first part is 1, and then sine of 0 is 0. So that is going to be 0. And then down here, sine of 0 is 0. So this entire first part is going to be 0. Plus cosine of 0 is 1. So these will both be 1. And so we end up with 1 over 1, which is 1. So that one is C. All right, this is the same thing, slope of the tangent line. That means derivative at pi over 2. So we're going to do the exact same thing that we just did. We're going to find x and y. X will be 4 theta cosine theta, and y will be 4 theta sine theta. And so again, it's going to be dy d theta over dx d theta. And again, they're going to be product rules. So this would be the first times derivative of the second plus the second times derivative of the first. And then same thing for x. So first times derivative of the second plus second times derivative of the first. And then we're going to evaluate this at theta is pi over 2. All right, so cosine of pi over 2 is 0, so that's going to go away. Sine of pi over 2 is 1, and then times 4 is 4. And then down here, sine of pi over 2 is 1. We're going to make that negative, so this is negative 1. And then 4 times pi over 2 would be 2 pi. So negative 2 pi. And then cosine of pi over 2 is 0. So this would be 4 over negative 2 pi, which would be negative 2 over pi. And so that one is B. All right, now this one is find a second derivative. So we're going to have to start by doing exactly what we did in questions 1 and 2, and then we're going to need to do the next derivative. And it's going to be at theta is 1. That's not on the unit circle. Like the ones we just did were on the unit circle, but this one is not. And you'll notice these are all decimals, so we are going to need a calculator. But it's going to start the exact same way as what we just did. X is going to be r cosine theta, and y is going to be r sine theta. So that would be sine times sine, so sine squared. All right, so dy dx, we're going to do this derivative. So bring the 2 down. It's going to drop to a 1, and then we're going to do a chain rule. Derivative of sine is cosine. And then down here, this is going to be another product rule. So first times derivative of the second. That would be negative sine. So this is going to be negative sine squared plus the second times derivative of the first. So derivative of sine would be cosine, so that's going to be plus cosine squared. Here's what you're going to do in the calculator. And you can be in polar mode or not. I'm in polar mode, so this will show up with a theta. If not, you can use x as the variable. It'll work out the exact same way because we're not graphing anything here. We're going to do this derivative, so the derivative of the derivative at 1. So I'm going to do math 8 for this, the derivative of what we just found at 1. And then we're going to divide by the denominator again. We're going to divide by dx d theta again. Okay. And let's see, put this in here. So we'll have 2 sine of theta, cosine theta over, now you can't type a squared, so this is going to be negative sine of theta, sine of theta. So that's how we're going to do sine squared. Just write it twice. And then plus cosine theta, cosine theta. And we're going to evaluate this at 1. All right, so that's the derivative of the derivative. And be really careful because that's a choice, but we're not done yet. I have to take this and divide by this dx d theta at 1 again. So I'm going to divide by this negative sine squared plus cosine squared. Yeah, but I'm going to put 1 in there. So negative sine of 1, sine of 1, plus cosine 1, cosine 1. And I put parentheses around that whole thing so that it would divide by all of it. And then this will be our final answer. So negative 27.752, and so that one is D. All right, number 4, a polar curve is given by this f of theta, so we don't have it specifically, just some equation there. The line tangent to the polar curve at pi over 6 is horizontal. All right, that means that dy d theta is 0. Which of the following things has to be true? All right, so we're going to need y. We won't need x in this case. We just need to set dy d theta equal to 0. So y would be r, which is this f of theta, times sine of theta. And so we're going to get that derivative, which again will be a product rule. So it's going to be first times derivative of the second plus second times derivative of the first. And we're going to plug in pi over 6 for the angle and then set it equal to 0. So if we plug in pi over 6, this will just be f of pi over 6. Cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is a half, and then f prime of pi over 6. And again, that all equals 0. It said we wanted a horizontal tangent line at that point. So let's see which one matches with this, and that is going to be C. All right, so number 5, what is the slope of the tangent line? So that means derivative of this at pi. So same as the first one and the second one we did. We're going to get x, get y, get the derivative, and then plug in pi. So x will be r cosine theta, and y will be r sine theta. And so this derivative, we're going to do dy d theta first. So we're looking at this one. So it will be first times derivative of the second plus second times derivative of the first. And then for dx d theta, so again, another product rule. So first times derivative of the second plus the second times derivative of the first. And we're going to evaluate that at, what was it, pi. All right, so this first part's going to be 3 pi squared. Cosine of pi is -1, so that'll be -3 pi squared. And then sine of pi is 0, so that whole part is going to be gone. Same thing here, sine of pi is 0, so this is gone. This would be 6 pi, and cosine of pi is -1, so this will actually be -6 pi. And so we've got -3 pi squared over -6 pi. So the negatives are going to cancel. One of the pi's is going to cancel. And then the 3/6 will reduce to 1/2. So pi over 2 for that one. So that is B. And then last one, at what xy coordinates does this polar equation have a vertical tangent line? So that is dx d theta equals 0. Now we're still going to actually need to get both x and y for this one because these coordinates are rectangular coordinates. We need them to be x and y, so we're going to need that y equation to be able to plug back into it at the end. All right, so x is r cosine theta, and y is r sine theta. So that's going to be 5 times sine squared of theta. So dx d theta, we're going to get this derivative. So first times derivative of the second plus the second times derivative of the first. And we're going to set that equal to 0. So this would be -5 sine squared plus 5 cosine squared equals 0. And you can divide everything through by 5. And so we'll end up with negative sine squared of theta plus cosine squared of theta equals 0. 0 divided by anything is just going to be 0. And so I'm going to add this sine squared to the other side. And then square root. So whenever you put the square root, you're going to have to put plus and minus. And so we're looking for places on the unit circle where sine and cosine are equal, but not necessarily the same sign as each other. And so that is going to happen at pi over 4 and 3 pi over 4. It'll happen at other places too, but this interval was only 0 to pi. So pi over 4 and 3 pi over 4. And if we were looking for coordinates in polar, we could just plug those back into this original equation to get r, and it would be r theta. But this one asked for x, y. So we're going to have to plug back into x and y to get points. All right, so plugging pi over 4 back in. We would have root 2 over 2 times root 2 over 2, which would be 1/2, and then times 5 would be 5/2. And then if we plug pi over 4 back in here, you'd have root 2 over 2 squared, which would be 1/2, and then times 5 would be 5/2. All right, and then the 3 pi over 4, the same thing is going to happen here. It's just cosine of 3 pi over 4 is negative root 2 over 2. So we're going to get the same result, but negative. And then this one, the exact same thing is going to happen. It'll be positive. This is squared. Plus sine of 3 pi over 4 is a positive root 2 over 2 anyway. So that one is going to be positive. And so that one is A.